Thanks for the reminder, Peter.
Right, first of all, I think it is a very, very interesting and very informative and well put together presentation. And it does give a very good overview. There can be lots of opinions. I personally think that the universe originated as from a quantum fluctuation of the vacuum. I think that's the most plausible. And I don't think we will be able to find out exactly what it is at the moment. We need new physics to do that. Secondly, I just want to specifically answer Elaine's question. Neutrinos, I think, simply put, you can regard as an energy balancing particle. So that's why you get, they are formed whenever you get a change from a proton. Whenever you get decay, radioactive decay, proton changing into a neutron. And it depends on the fundamental particle emitted as a result of the reaction. That could be from beta decay, it could be in the fusion center of a star, it could be in a nuclear reactor, it could be in a hydrogen bomb, or in fact, even an atomic bomb, or it could be in a winding down of a neutron star. So it carries away the energy, and that's why you get electron neutrinos, you get positron neutrinos, you get tau neutrinos, etc., etc. But I think charge and mass must always be conserved. And when there's a change in the mass that we measure, the difference in energy is carried off by the neutrino with the characteristics of the elementary particle that is emitted. I think that is a fairly simple summary answer to your question. No.
Okay, thank you, Pierre.
All right, anybody else got questions? Otherwise, I've got a few. Peter, I'm sure you've got a question. Peter? All right, nobody's good question. Can I ask one then? Right, the monopoles. Pierre, I don't know if you can give us some detail on this. It seems to me almost like an obsession with having to find why do people need to find a monopole? I mean, to me, it's like you have a coin, you have heads and the tail sides of a coin. Why must you have find the head in one place and find the tail in another place? It's two parts of the same thing. Why do you have to have the thing on its own? Can you give us any insights there, Pierre?
The answer to that is simple. I don't know.
It doesn't make sense to me.
No, it doesn't. I agree with you.
All right, that's quick and easy. I'm sure if you look into the theory, they must have some mathematical backup for why they're looking for it, but I don't understand it. Obviously, it's something I don't know. All right. The standard view that the universe is smooth. I mean, that's been proven not to be accurate with some fairly big structures being found and all sorts of things. So the universe is not entirely smooth. So that sort of goes against that whole one of the things for the inflation, justifying inflation. I just wanted to make that comment. You got any comment on that? Yeah, Chris?
I think the statement is made that the universe looks uniform on a very large scale. In other words, even larger than the largest scale structures that we observe now. Because if you come down smaller, there are distinct differences. And he made the point in the talk that originated from fluctuations just after the Big Bang and then was frozen into the universe by inflation. I think for me, one of the most fundamental questions is what caused inflation? Because that goes against all different concepts that you get such a rapid expansion in so shortly after the universe formed. It did answer a lot of questions, but there must have been something that drove it, and I don't know what it is. So that's something I would still like to learn more about, inflation.
Yeah, I sometimes wonder on that if it wasn't something slightly different which happened. Like you've got the vacuum fluctuations, quantum fluctuations in space at the moment. What if that always existed throughout space, and then what happened was with inflation was not that there was sort of like analogous to an explosion expanding outwards from a central point. What happens if there was something like when so you've got a container of water in a deep freeze and it goes below freezing, but it's still liquid. It's sort of super cooled water, but it's below the normal freezing, but then it just something jiggles it slightly, and you have the whole thing freezing at a very rapid rate from a point. So there was a bubble or something, I don't know which. So what happens is you don't have an explosion traveling outside, you have a change traveling outwards at a rapid speed, where everything that was at the distance from that point was almost in the stage where it was, matter, say, for example. So you've got like everything changing sort of throughout the universe at that size. It's not an explosion where everything was in the point in the center and then expanding outwards, but it was a change in the vacuum fluctuation background. So that's sort of one concept where I don't know if anybody's thought of a concept like that or whether it's possible or it makes sense, but that's the only way I can get my head around something expanding in sort of 1/trillionth of a trillionth of a trillionth of a second to the size of a grapefruit or whatever. I don't know what you think of that. It sounds like nonsense.
A nucleation event.
Yes, something like that.
Well, that's very intriguing. I have to say that I'm sort of none the wiser. I mean, I'm very weak on cosmology, but every explanation I hear sounds to me like a sort of tautological infinite recursion, like we say that the universe came into being because of a fluctuation, a quantum fluctuation in a vacuum. Now, a vacuum is a volume of space in which there is nothing, right? But the volume implies that there is size, right? And the size might be independent of its contents, but size indicates an existence, right? You can't have a size of nothing, right? So you say, well, how is this possible? And every explanation sort of devolves recursively, to sort of, and infinitely. It's not. I don't see us getting closer. There are explanations that might help us within a fixed time frame, which is, of course, our universe that we perceive. And that's all very well, but the question of what came before, I mean, even time didn't exist before. So how can you say before? So it's really a metaphysical conundrum in that I can't get to grips with, and I would be happy to have a handle on this, but
as far as the nothing is concerned, I see the nothing as being no matter, no physical matter, no gaseous or solid or liquid matter, or even ionized matter. So you can still, as far as I'm concerned, you can still have energy, which has theoretically no mass. So from that point of view, it's nothing with mass, as far as I'm concerned. And
but
energy gets converted to mass, I think.
But this doesn't get us closer to the beginning of the universe in the sense that was then the universe, right? So how did that happen? How does a space that might have some intangible energy in it, but how does the space come into being? You know, I mean, it's
somewhere somebody's finger gave a flick, and that started it off.
yeah, but now we're saying that somebody, you see, and that finger, right, that pre-existed all of this.
Yeah.
And you know, we even say that, you know, time started at the beginning of the Big Bang, and so saying what's before is sort of nonsensical in that if there was no time, then how could there be a before? You know, I mean, all of these things are really like metaphysical on a level that I really grapple with. You know.
Yeah, well, I
would love
don't think it's possible for humans to comprehend that, you know,
Yeah.
if there's something that created something, what created the something that created the something? And it's a
Yeah,
never-ending.
so I say
It is an infinity as far as I'm concerned.
yeah.
All right. So, other questions I've got, where he mentioned that was talking about the black holes, I think, and he was talking about particles and antiparticles, and he says particles move forward in time and antiparticles move backwards in time. I find that to be rather nonsensical. Why should antiparticles move backwards in time? As far as I'm concerned, nothing can move backwards in time. Why should antiparticles be able to move backwards in time? Any comments on that from anybody?
I agree with Eric, it sounds nonsensical.
If something can move backwards in time, right, that means that we should have a record of things that have happened due to this.
Yeah, but I mean, I can find that. I think it was in the 35th minute. If you don't believe it, but that's what I heard. All right, so that's the some of the questions that I've got. I think. I mean, there's probably thousands of others if you carry on digging.
I think the business of antiparticles moving backwards in time is somehow trying to preserve a symmetry in the system.
Yeah, I think it's something that maybe comes out of the mathematics. To me, if it does, then the mathematics needs adjustment. I don't know.
Mm-hmm.
So,
yeah, well, it still begs the question of why should time have a direction that's immutable?
Chris, if you want to spend another 3 hours, get me started on time.
I think 3 weeks is more appropriate.
My basic view of time is that time doesn't exist. It's artificial construct of the human imagination.
You
nature's way of preventing. Time is nature's way of preventing everything from happening at once.
Yeah, well, it can't happen at once because time doesn't exist.
you must remember that there are causal consequences. And I think that ultimately defines the direction of the arrow of time.
Yeah. Okay, let's not get into that. Otherwise, we will be here all night.
That's teleology, the doctrine of final causes.
Yeah. So, yeah, okay. Any more comments, questions, everybody? Just get the attendance up, see if everybody's still here. You've disappeared.
I just would like to say that I think Chris Stewart summed it up with his metaphysical conundrum. It means, quite honestly, that cause and effect totally loses validity. It becomes, it goes back to natural philosophy as against science.
Yeah, there have been in the last couple of years, there have been some people who have been putting forward some pretty clever reasoning as to why they can go back to before the Big Bang occurrence. I have seen articles like that. I'll maybe dig them up. I think it was, what's the guy who's the cyclical
Roger
University.
Penrose.
Penrose, yeah, I think it was him.
It was him.
Yeah.
And I think those ideas contributed ultimately to him getting a Nobel Prize at a very advanced age.
There's been some new stuff by him just in the last couple of weeks, but I haven't looked at the detail. So I'll dig that up as well. It's quite interesting. All right. Did you find that okay?
No,
Yes,
it was very,
good.
very interesting.
Mind-boggling.
Yeah. Every time I watch these things, I just learn more about what we don't know, I think. Learn more about what we need to find out than anything else.
I think you've hit the nail on the head there, Derek. We learn more about what we don't know.
Well,
And
you're
it's
expanding the
I think very
circumference.
scary.
We are continuously expanding the circumference of the circle of our ignorance. So the bigger the circle, the more we realize we don't know.
Yeah.
Well, fundamentally, it's important to ask these questions, of why and how, right? If we are to progress. So I'm happy that there are people with great intellect working on this. But I'm not convinced that in my lifetime there's going to be any explanation that I'll be able to comprehend.
When they've built that other bigger, Large Hadron Collider, maybe we will then. I don't think they've found anything significant since the Higgs particle. So I think they're talking about building a much bigger Hadron Collider. So we'll have to wait another 30 years or something until that's finished.
Ah,
How old will I be then? 98. Okay. All right. Hopefully by then we'll have better medicine and I'll be able to live to that age. All right. Thanks everybody for attending. If there are no more, let's go and have our supper and a beer or a glass of wine or something.
Thank you, Derek.
No more
Right,
questions?
thanks.
We log off.
Bye.
Thanks very much for attending. Everybody.
Sorry, could I just raise another topic?
Yeah, sure.
It's quite interesting that a student friend of mine who actually studied BA, not BSc, had a son that studied medicine and he did very well. He actually ended up top of his class and then he was killed in a motor accident shortly afterwards. And he phoned me and he said his son was intellectually very inquisitive. And he collected a number of books during his lifetime, which he asked if we would be interested in. I've got the whole stack of books here. I'm going to open it and write down a list of it. Some of the books, I think a lot of us have. Stephen Hawking's books, he liked him. And there's even one by Roger Penrose. So I'm going to compile a list and send it to Peter and send it to any member who wants to borrow the books to read, free of charge, obviously. Just have to collect them or keep record of it somewhere. But it's quite impressive that a medical student could read so much in his spare time on cosmology. If you see the list of books, you'll realize what I'm talking about. I'll make a list and send it to Peter for distribution to our members.
Please, thanks very much. Yeah. I'd maybe be interested. I don't think I've got any books by Penrose actually. All right, so for the next time, our next session, number 12, is the title is, Was Our Current Universe Already Inevitable at 1 second old? So we just seem to be staying in this sort of theme. All right, so that'll be for next time. All right, thanks very much for attending. We look forward to your list of books, Pierre. All right.
Thanks, everybody.
Everyone.
I'll stop.
Thank you, everybody.
We can log off.